Well, hello everyone, what's up? This is page 403. We're continuing our properties of quadrilaterals activity. And in this one, I want to go ahead and just move forward with what we're doing. We're talking about the other bullet point on the flowchart that said that the diagonals of a parallelogram bisect each other. So I've got the information here. I'm going to kind of hide my words for a minute. All right. Got the information here that says we have this triangle, we have this parallelogram parg, and we are going to use what we already know. We've already got in the bank. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. Now let's go ahead and show how the diagonals are actually bisecting each other. Remember, bisect means to cut in half, and so if we see the word bisect ever pop up, that thing has been divided into two equal sections. So the first thing we should do to show that, well, what are the diagonals? Like AM and GM are two halves of that long AG diagonal. PM and RM are the other two halves of the other diagonal PR. And to show that they are congruent, which would be our way of saying bisecting, we need to show that the triangles that I highlighted in green, there are actually 4 triangles, right, that are created, and maybe like an additional 4 more if you count the larger conglomerates. But this one, PGM, and this one, RAM, they're congruent. This can be done with angle, side. So the first thing we can do is we can prove the angles that are congruent. And I want to kind of maybe zoom out a little bit. Show it all right there. Yeah. Okay. This can be done by showing that the angles themselves specifically are congruent. So we can say like PMG, so that's PMG, that's this one right here in the middle, and this other one, RMA, they are congruent because they're vertical angles, and vertical angles are congruent. That is a theorem that we've done. The next one up for us is MGP and we'll make my letters right, MAR, there we go. So MGP and MAR, they are congruent because like we did in the previous videos, when we proved that they were the same, they were alternate interior angles. And when the lines are parallel, there's a theorem that says those angles have to be congruent. Last of all, just like we did in that video, the angle, well not actually, this is a result of what we did on page 401. PG and A and RA. PG and RA, those sides are congruent because they're sides of a parallelogram. Therefore, with angle, side, matching angle, side, those two triangles have to be congruent. So their parts have to be congruent. Specifically the part PM and RM, those are congruent. And the part AM and GM, those are the parts that are congruent. By corresponding parts of congruent triangles are congruent. CPCTC. Which one's doing it right? Okay. Well, Smarty Pants Ray gets up there and he says, you know what, I believe that we could prove a shape, a quadrilateral, is a parallelogram if only one pair of opposite sides is known to be both parallel and congruent. And he is 100% correct. I gotta let you guys know this is worth highlighting. That's almost a note card statement. If you have just two line segments, and they are parallel and they are congruent, well, like so, connect their endpoints, and you make a parallelogram. Everything that we get from there is considered true, right? We could draw the diagonal, draw the other diagonal, right? We're just sketching in the parts that are come after the fact. Ray only said opposite sides are congruent and parallel. That's all that he said. And so for that reason, we have to provide the rest of the shape. But when you do, when you provide the rest of the shape, like these two sides, well, they're like transversals. So these two angles will have to add up to 180 degrees. And these two angles will have to add up to 180 degrees. And they're the same angles. Opposite angles are congruent. We'll have this distance between these 2 points. It'll match the distance between those 2 points. So that means that those sides are congruent. And then last of all, because of the triangles that are created, this diagonal is totally and perfectly bisected by that triangle, which is also being bisected, so the diagonals are congruent. Ray is 100% correct. You should remember this. You should think of Ray whenever you think of two sides, but only that's all we get. We don't get a pair. We don't get more than that. We just get two sides. You only know that those two sides are congruent and parallel. That means this entire shape must be a parallelogram. Thanks for watching. Bye.